So there are loads of examples where you might be writing code and you want to have a number of different variables all stored together within one. And in Python, the most common way to do that is with a data type called a list. So a list represents multiple variables all packed together in one. In Python, you represent lists with square brackets, and then each variable inside is separated by a comma. So that looks something like this. So here I've got a list that contains 3 different items. It contains a string, an integer, and a Boolean data type. And so that should make it pretty clear that lists can contain data of different types. They don't all have to be the same. The items inside a list are indexed. That means that you can get them out by asking for an item at a particular position. And in Python, one thing that's really important to notice is that everything is 0 indexed. So that means the first item in a list, for example, is going to be represented by the 0th position. So if I wanted to get the first item out of my list, I would get the name of that list, put square brackets after it, which always means I'm going to index it, and then I put a 0 in those square brackets. So that's me indexing the first item in the list, and I've got to do that with a 0 because Python is 0 indexed. To get the next item, I'd use a 1. And to get the final item, in this case, I could use a 2. If I index out of range, then I'm going to get an error. It's an index error, and it pretty clearly tells me the list index is out of range. So if you see that, you know that the index you're trying to use is higher than the number of items inside that list. Instead of indexing from the beginning of a list forward, you can also index in the opposite direction by using negative numbers. So if I wanted to get the last item, I could index this list with a -1, for example. And that would get me the final item. Lists allow what's known as slicing. Slicing gets you a range of items from a list rather than just a single item. So if I want to slice out the second and third elements of my list, I could write something like this. So it's the same square bracket syntax, but this time I've got 2 numbers, each separated by a colon. The first number represents the index of the item which I want to start at, and the second number represents the index of the item which I want to finish at. Now, it's important to note that the result will include the item at the first position and not include the item at the last position. So if I run that, I actually only get the 3. And that's because, as I said, the slicing range is inclusive of the first index and exclusive of the last. So to give a better example, let me make this list a little longer. So now if I slice that list, I get these items back. I get 3, true, 4, and 5. And so those are the items in position 1, 2, 3, and 4. So here, again, you can clearly see that the slice is inclusive of the item in the start position. So in position 1, 0, 1, it's going to include that number, the 3 in this case. But the slice is exclusive of the variable at the stop position. In this case, that's 5. So the item in position 5, 0, 1, 2, 3, 4, 5, which would be 7, is not included in the result of the slice. And you can see that down here. You might expect Python to throw an error if the slice index is out of range, like we saw the index error if the index is out of range. But if the slice indices are out of range, Python will just go as far as it can in either direction. So that might look something like this. Clearly, my list does not go up to 5,000 different elements, but if I run that, I don't get an error. Like I said, Python just goes as far as it can in that direction. And so here I get from position 1 all the way up to the end of the list. The same thing works with the start index. If I were to, for some reason, give a negative index to start with, well, it's going to go back as far as it can, which of course is just to the beginning of the list. So this thing here is going to get me the whole list. And the same thing is true for negative indices wherever you put them, whether it's the start index or the stop index. So if I were to do from index 3 to -500, obviously -500, 500 in the reverse direction from the end is going to be all the way up to the first item and beyond. So actually, I'm going to index from the third item all the way up to some point before the first item. So the result of this, if you hadn't guessed it, is going to be empty. There's nothing within that range. If you don't specify the upper or lower bound, Python will assume that the lower bound is 0, the beginning of the list, and that the upper bound is the maximum length of the list, so all the way to the end. It will assume a default -1. So if I remove the upper bound, run that, it gets me from 3 onwards. And this is really handy if you don't know how long the list is. And the same in the opposite position. If I leave out the start index, then run that, then it's going to get me from all the way from the beginning up to, but not inclusive of, index 5 in this case. If I leave out both, well, then it gets me the whole list, assuming 0 as the default start index and -1 as the default finish index. So now I'm going to make an even longer list, just to show you what you can use a third index for. So you might not have seen that coming. So if I were to add a slice like that, what this syntax says is starting at the second item in the list, go all the way up to, but not including the 8th item in the list, in steps of 2. So that final part of this slice there, the second colon, that's specifying the step size. So if I run that, I'm going to go from the 0, 1, 2 second item up to, but not including the 8th item, 3, 4, 5, 6, 7, 8, up to, but not including that, in steps of 2. So I should get back true, 5, 8. Run that, and sure enough, that's what I get back. Lists have 2 main characteristics. They are mutable and they are ordered. You probably guessed that ordered means they have a defined order, and this order is not going to change. Mutable, on the other hand, means that the items in the list are changeable. So we can replace, add, and remove items and do whatever you want. You can change that value of what's inside the list. So an example of this would be, I can manipulate my list by getting something at a specific index, let's say in the 3rd position, which in my case would be 0, 1, 2, 3, with this 4 value, and I can set that equal to something. And by doing that, I've actually changed the list. I've mutated it, which is why they are mutable. And so now if I print my list and run that, then you'll see in the position where I've overwritten that 3rd item, I've got this 67 value. So right now, we know how to define a list and access the items in it, do all kind of slicing, we know that they're mutable and they're ordered. But lists can do even more than that. And to see a few of the things that your lists can do, just write out the name of the variable, hit the dot operator, and then it will show you a bunch of different functionality which lists have. So this dot operator used to access the different things that the list can do. So in here you can see it's got a bunch of different things, including, let's say, reverse. That's a simple one. So this thing here is a function. So I can call this function. So if I run that, it doesn't seem to give me anything in the output, but that's because this function is an in-place function. So what that means is it doesn't return you anything. It doesn't give you anything that you could assign to a variable like that. This is going to be none. Instead, it actually changes this variable in place, which is why it's called an in-place operation. So now, if I were to print my list, then you see it's been reversed. So that's what the reverse method does. Another method of lists which you're certainly going to use is append. So append can be used to add items to a list. So if I were to run that and then show the list, you see that it now includes another item. There's a very similar method which can cause some confusion, and that is extend. So whereas append is for adding single items to a list, extend is to combine a list with another list. So if I have my list and I do .extend and then pass in here another list, then my list is now going to have those 3 items joined separately to it. If I were to do the same thing with my list append, then what you'd see is that append hasn't added each item individually. Instead, it's added that whole list as an item in the list. So, surprise, lists can contain more lists. So you can have a list of lists of lists, and so on. They can be nested however deep you want, actually. So if you want to add every item in a list to another list, then use extend. If you want to add a list as an item individually to a list, then use append. That's not so important, but it always causes some confusion. So now we know how to add things to lists. Let's imagine we wanted to remove an item from a list. I'm not just going to tell you how to do this because most of the time you're not going to have someone to tell you how to do it. So instead, I want to show you how I'd go about figuring that out, right? So let's say, okay, I've got this list, my list, I want to remove something from it. Well, in that case, I'm just going to go straight to my browser. I'm going to search in here Python, name of the programming language I'm using. I'm going to search list and then remove item. So I've kind of broken it down step by step, starting off with the programming language I'm using, then what I'm doing in that programming language, I'm using lists, and what I want to do with the item, remove item. So if I run that, you see the first thing that comes up, it's a remove method, apparently. So, okay, I'll quickly scan over this. How does it work? There's an example down here. I can see they're using a list, and they do .remove and specify the item which they want to remove. And you can see that if you try and do that with an item that isn't in the list, then you get an error. There's another method which you should definitely know about. And here we can find this one in W3 schools. So they've got the remove, but they've also got pop. So pop, what that does is instead of specifying by value where you want to remove, you specify by index. So another useful thing about pop is that it doesn't just remove the item from the list, but it also returns it. So I could assign it to a variable. So if I wanted to say, get the first item in a list at the same time as I remove it, then I could do mylist.pop 0 to get out the first item there. Then if I were to print first item and run that, then I get world. That's the first thing in my list. Now, if I run this again, I'm going to get a different item because the list has now changed and now I'm removing a different item. The default value is the last item in the list. So the default value is -1. So if I run that, I'm going to get the last thing in the list, which is my 1, 2, 3 list, which I added earlier. If I run that again, I'm going to get the next thing in the end of the list, 3. If I run it again, I'm going to get the thing before that. And now if I were to print this list, you'd see it's had all of those items removed. The final thing I'll show, which is probably the most basic functionality of lists, is that you can calculate how many items are in the list using Python's built-in len method. Do something like that, it shows you how many items are in the list. And that's more than a good enough of a start to get using lists in your code.